Hello everyone, welcome to our UN College digital class. So as software engineering is concerned, the case studies or the real life examples are much more essential. So in this particular video, we are going to discuss on a case studies or a real time example. Okay. If you remember one of our previous video, we have already discussed the different types of application software. So there are embedded control software, there are data collection softwares, there are simulation and system modelings, there are standalone software. So among those softwares, here we have a embedded control software, that is insulin pump control software. Okay. So insulin pump control system is an embedded system. So as we mentioned that insulin pump control system is an embedded control system, then we should remember two things. The first thing is it is not purely a software system, and the second thing is as it is an embedded system, that means just try to recall what is an embedded system. So embedded system is the combination of both hardware and the software. That means the software that is embedded with that system is completely responsible for the working of all the hardware systems. Okay. So the hardware, all the hardware systems, those are embedded into that particular system is completely controlled by the software system. So the second thing is the software system is responsible for controlling all the hardware systems, those are embedded to that particular system, or we can call as the software is the heart of our embedded control system. So insulin pump control system is an embedded system. Then what is this insulin pump control system, how it works, and what are the purpose for such system, here we have to discuss. Okay. So I hope all of you are familiar with diabetic patients, and the sugar is nothing but the blood glucose level. Okay. So there is a very normal process that how should a diabetic patient should take his treatment, like their blood samples should be collected in a regular basis, that means on a regular basis or on some regular interval time or on monthly basis, or in each 15 days their blood samples should be taken. Then from their blood sample the sugar levels should be calculated, and that sugar level should be compared with the previous readings, those are kept as records, and based on that the doctor will decide how much of insulin dose that the patient should be take. Okay. And I think you might have come across that there are many diabetic patients which who are much more expert in that. In their resident itself they are taking insulin on a regular basis. Okay. And the insulin that are injected to their body is done by manually through the injections. So whatever the systems or whatever the process that is done manually, that can be done by an automatic embedded system, that is the insulin pump control system. So the insulin pump control system is a automatic embedded system that can be attached to a patient's body. Then that system will collect data from the blood sugar from the patient's body. Then the system will be capable of calculating what are the accurate sugar level, and based on that sugar level the pump should inject that much of insulin into the patient's body. So let us discuss what are the hardware architecture of insulin pump control system, what are the different parts that are embedded to that insulin pump control system. That means as we mentioned that insulin pump control system is an embedded control system. So there should be some hardware and there should be a software. That software is responsible for the working of those hardwares. So let us see what are the hardware architecture of the insulin pump control system. So this is our basic hardware architecture of insulin pump control system. We have some hardwares and we have a software, that is our controller. Okay. So let us see how it works. So first we have a needle that is assembled to the embedded system, and we need that needle to inject some amount of insulin to the patient's body. Next we have a micro pump. That pump is going to move the correct amount of insulin to the patient's body through this needle. Okay. Then the next is we have a clock. Why we need a clock? We need a clock to measure the sugar level in a fixed interval of time. We can fix that time, and for that fixed interval of time, the clock is going to measure the sugar level, and based on that sugar level, the correct amount of insulin is going to deliver to the patient's body. Next, we have an alarm. If something goes wrong with the patient, or if something goes wrong with this system, then the alarm will alert that patient. Next, we have a sensor. This is a blood sugar level sensor. That sensor is responsible for sensing the sugar level or blood sugar level from the patient's body, because this system is attached with the patient body, and the sensor is responsible for sensing the data of the sugar level from the patient's body. Next, we have two displays, display 1 and display 2. These display 1 and display 2 are responsible for showing the time, the power supply, how much powers are remaining there, and how much of insulin dose that is to be injected to the patient's body. So, those information will display on these two display areas. Next, we have the controller. So, all these things, that is needle, pump, clock, alarm, your sensor, display, screen, all these are the hardware devices, and the central thing, or what we can say that the heart of the embedded system is the controller. This is the software, the responsibility of the controller to control all these hardware devices. So, these hardware devices are need to be connected to this controller. And apart from that, there is the insulin reservoir. So, why we need a insulin reservoir? Because the patient is using this device, or the patient is using this embedded system on a regular basis. So, there should be some amount of insulin should be reserved there in a insulin reservoir. Some insulin should be kept as in stock in this insulin reservoir. So, whenever the patient requires, or whenever the blood sugar level will change, that much of insulin should be come into the pump, then the pump will deliver that insulin to the patient's body through the needle. And for the proper working of all these things, there should be a power supply. So, we have a power supply here. So, this is the basic hardware architecture of a insulin pump control system. So, let us see how this particular system is going to work. So, we have a blood sugar sensor that we have seen in our previous diagram. So, that blood sugar sensor will collect the sugar level data from the patient's body, then it will calculate the correct amount of insulin that is required to be injected to that patient's body. Then this is the first thing, that means the blood sugar sensor will collect the sugar level data and calculate the correct amount of insulin that is required to be injected to the patient's body. And the second thing is, the calculation is always based on the rate of change of the blood sugar level. Okay. So, what is this rate of change of blood sugar level? That means it is always important that how the system will come to know whether the blood sugar level is changing or it is decreasing. Okay. So, this is a very important aspect, how the system knows that the blood sugar level is increasing or decreasing. That is based on every time the system will take 3 inputs, that is 3 minimum inputs. The first one is with the current reading, that is the current blood sugar level, that is suppose R1, and there are 2 other readings, that is the previous readings which have stored in our database, let it be R2 and R3. Then the system will compare the current reading R1 with the R2 and R1 with the R3. Then based on that, the system will capable of calculating what the correct amount of insulin should be injected to that patient's body. Then based on that calculation, then the system will send signals to the micro pump to deliver the correct dose of the insulin. See, this is a very important thing, because any wrong information, or if system will send a wrong information to the micro pump, then the micro pump will deliver a wrong amount of insulin to the patient's body. That will be very dangerous to that patient. Okay. And the next important aspect that we have to remember is that the insulin pump control system is a safety critical system. Look at the name, safety critical system. That means the system is a safety critical system. So, why this is a safety critical system? Because this embedded system is attached to the patient's body, and the patient is regularly using this embedded system. So, if anything goes wrong with this system, then it will be very dangerous to that patient, or it may cause death also. So, at the same time we have to remember that low blood sugar can lead to brain malfunctioning, coma, and even death also. At the same time, high blood sugar level have a long term consequences such as eye and kidney damage. That means, if the system is going to calculate the insulin dose wrongly, and based on that wrong information or wrong insulin dose, the pump will deliver the wrong insulin dose to the patient's body, and then the patient's sugar level will be high or will be low according to that wrong information. So, that may cause many serious damage to any organ, or that may cause death also. So, we can say that the insulin pump control system is a safety critical system. So, now just have a look into the activity model of insulin pump control system. So, whenever software engineering is concerned, so before going to develop any system, first of all we should represent that system in a graphical manner by using some system model. Okay. So, the activity model is one of the system model. So, before going for the real time implementation of that software, we should represent that system in a graphical representation way. So, this is the graphical representation of insulin pump control system. That means, how the insulin pump control system works. This is the activity model. As we know that software is not just a program, the software is collection of program along with the documentation. So, whenever the documentation part is concerned, the activity model itself act as a documentation. Okay. So, suppose someone asked me to write the software for this insulin pump control system, then this activity model will help me to code the software. So, let us have a look into this. So, first we have a blood sensor. Okay. First thing is, we are using two type of notation here. One is a rectangular shape and other is oval shape. The rectangular shapes are used for storing data, and the oval shapes are used for processing of those data. So, first we have a blood sensor that we have seen in our previous diagram. We have a blood sensor that sends our blood sugar level from the patient's body. Then what will happen? Then it will analyze that blood sensor and it will analyze that sensor reading. Then after that it will get the what is the blood sugar level of the patient. So, in the third part, here the blood sugar level, what is the accurate blood sugar level will be stored here. Next, based on that blood sugar level, then it will, the system will compute the insulin. Okay, how much of insulin dose the patient need to be injected. So, after the computation of insulin, that correct amount of insulin dose will be stored here. Next, based on the insulin dose, then we will compute the pump commands. That means, we will command the pump that it will be deliver these amount of insulin dose to the patient's body. Next, after giving command, it will compute the pump data. That means, how much of insulin it will be get injected to the patient's body. Next, it will control the insulin pump. This is the activity. Okay. Through this control insulin pump, through this activity, the correct amount of insulin is going to injected to the patient's body through the needle. Okay. So, this is the overall working. Then what this insulin log and log dose. So, what is this? So, as I said that how much of insulin is computed based on two factors. First one is the current reading, what is my current blood sugar level, and then the current blood sugar level will be compared with the previous two readings. Then this log dose will help me to give me the previous two readings. Suppose I am using this system for the first time. Okay. I am just skipping all these steps, coming to the compute insulin. So, first time my system compute that I want x1 unit of insulin to be injected into my body. So, this is my first reading. Okay. So, after computing x1, the x1 will send to the pump command, that means the pump will inject x1 amount of insulin to my body, then that x1 should also be here, that means in the log dose. This is the database where we are keeping all the previous records or the previous insulin dose that we already have taken. That means the x1 will be sent to two systems. First one is your compute pump control, here x1 will become, and next the x1 will be sent to the log dose. So, we have the x1 here. Okay. Next, for the second time, suppose for after 1 day or after 15 days, when we calculate that insulin in this activity, suppose we have calculated that we want x2 amount of insulin dose. So, this is our second reading, that means for the second time the current reading is x2. We have computed that x2 amount of insulin should be injected, but what actually the insulin dose should be injected to our body, that will be compared with the previous reading, that is x1. So, x1 will go to the insulin log. So, we have here x1 and here we have x2, then x2 and x1 will be compared. Then after the comparison, we have, suppose we have found, suppose what, y1, we have found y1, then inside the insulin dose y1 will be get stored, then y1 will go to the compute pump command and also y1 will go to the log dose. So, the previous reading was x1 and the next current reading is y1. Okay. So, suppose after 15 days again we have to read what is my sugar level, and here suppose we got x3. Okay. We got that x3 amount of insulin we need, but what is the actual need of insulin dose? Then we have to compare that x3 with the previous reading, that is x1 and y1. So, x3 is here, x1 and y1 will go to the login dose, will go to the insulin dose. So, here is x1 and this is y1. Then x3, x1 and y1 will get compared. Then after the comparison, what will be our third dose? Suppose let it be G1. Okay. Now, the G1 will send to the compute pump command, that means for the third time I need G1 amount of insulin dose to be injected into my body, and that also G1 will send to the log dose. So, this is basically the database where we are storing what are the insulin dose that we are getting injected into our body for every time. Okay. So, here we have for the after the third reading we have x1, y1 and z1 in the log dose. So, for the fourth time if I am going to compute the insulin dose, then that current reading will compare to the last two readings, that means G1 and Y1, X1 will not be compared. So, this is how the insulin pump control system is working. Next, just have a look into the essential high level requirements that we required in case of insulin pump control system. So, the first thing is the system shall be available to deliver insulin whenever it is required. So, if you remember in our previous class when we have discussed the good attributes of a software, there we discussed that each software should have some good attributes, and that term dependability was there. Dependability is a very good attribute of a good software. That dependability comes with 4 other attributes. One is your availability, second is your reliability, third one is safety and your security. So, safety and security we have already discussed that the insulin pump control system is a safety critical system. Next we left with availability and reliability. So, the first thing is the insulin pump control system should be available to deliver insulin when required. That means it should be available 24/7 because that system is get attached with the patient's body. So, whenever any changes occurs in the blood sugar level, the system should be available there to inject that correct amount of insulin to the patient's body. And the second thing is there is a insulin reservoir we have seen in our headed architecture. So, in that insulin reservoir some amount of insulin should be kept in stock because the patient is using it on a regular basis. If the insulin reservoir does not have any insulin, then what will happen? The patient will require some insulin to be injected, but the insulin reservoir is empty. So, there should be some amount of insulin kept in a stock. Okay. The next is the system shall perform reliably. Okay. That means whenever we call a software as a dependable software, the second attribute comes that the system should be reliable. That means it should compute the correct amount of insulin dose that is actually required to be injected to that patient's body. So, these are the two high level requirements. First one is the system should be available 24/7. That is why there is an alarm. If something goes wrong with that system, the alarm will alert that patient. Okay? And the second thing is the system should be reliable. That means under the dependability there a second attribute that is reliable. So, when we call a software as a dependable, the software should be reliable. That means this particular system should be calculate the correct amount of insulin dose, and that correct amount of insulin dose should be injected to the patient's body through the pump control and the needle. So, these are the two basic essential attributes or basic essential high level requirements of a insulin pump control system. That means the system should work properly, the correctness of that system is highly required. So, whenever we concern the insulin pump control system, we expect that the system should be available there 24/7 and the system should perform reliably to deliver the correct amount of insulin to counteract the current level of blood sugar. So, the system must therefore be designed and implemented to ensure that the system always meet these requirements, that is availability and reliability. So, as per our syllabus is concerned, there are 3 case studies. One is insulin pump control system, second is your weather information system, and third is mental health care system. So, we have completed the insulin pump control system in this particular video, and in our next class we will go for the mental health care system and weather information system. Thank you.